In this sample problem, we're going to take a look at a problem that gives us some information we need to answer questions for. And we're not necessarily going to graph, per se, the quadratic, but we can use the techniques that we learned graphing here to help us answer the question. So if we look at this, sample problem number 3. A record label uses the following model for sales of new releases. And you can see that it has a degree of 2, so it's a quadratic. The number of albums sold is A, is a function of time and T in the number of days. And so we want to know which day were the most albums sold. And so you would think of this as basically the maximum amount. Now, if you just drew a generic version of this quadratic, you can see that it says -90, so you know that it's going to more or less look something like this. And it's going to have a point up here at the top, and that point is going to be an input of T with an output of A. And of course, you can see that right there, in the given function. So what we need to do is we need to find out when the most albums were sold. So we want to know when we have the most A values. And if you look at this chart, or this graph of the quadratic, you can see that its maximum point, or its vertex, would represent the highest A value, or Y value in generic terms. So we basically just need to find what day that we have the highest A value. Okay, so it says which day was the album sold. So basically the T represents the day that's matched up with that A on the vertex. And so we're going to simply say X equals, and of course that's our T, -B over 2A. And so we can see that this is going to be -8100 over 2 times -90. And of course our T here is going to equal to 45, and of course that represents the number of days. So on our vertex, the T is going to represent 45 days. Now, part B asks us what is the maximum number of albums sold on that day. So now we just need to simply evaluate this function at the 45th day so that we can come up with the number of albums that we have. And this is where we're going to use our calculator effectively. And we're going to just plug that into our calculator, and on the 45th day we're going to see that we've sold 182,250 albums. And that would be the answer for part B. Alright, for this last sample problem, we're going to use our graphing skills for a little different type of problem here. What we've been given is a model of a function of a ball that's being hit in the air, and then of course is eventually going to come back down and hit the ground. And they want to know in the first part how long the ball stays in the air. So what I'm going to do is I'm going to just kind of give myself a visual of what that's going to look like to start, and I'll just basically draw the graph here. And of course it started roughly about 4 feet off the ground, went up, came back down, and hit the ground. Now keep in mind that the height is over here and the time is over here. So we're trying to figure out in part A about how long the ball was in the air. So we want to know how long it took until it came back down here and had a height of 0. That's where it hit the ground right there. So it was in the air from the time it came off the bat right here at 4 feet off the ground. It was in the air all the way until 0. Now later on in this unit we'll have actually a more mathematical way to solve this and get an exact amount of time, which is when we could plug in a 0 for the output and make the entire quadratic equation equal to 0, and then we would solve the quadratic equation through one of the methods that we're going to teach you. However, since we're not to that point right now, we basically only have the graph to work with, and we really don't have a way of solving this 0 yet, but we do have a way of solving this maximum. We can get a sense of how long it's going to take until it gets to its maximum height by finding the vertex. And so what we're going to do, we're going to find the T for time, and we're going to use our A, B, and C values necessary to plug into this. And so we need -120 over 2 times A, which is -16. Which is going to give me roughly 3.75. And so what that means is that's my time at the height. Okay, so at the height of the the maximum height of the ball, it took 3.75 seconds to get to that point. Now, what you're going to learn later in physics and kind of come to understand is that these quadratics are traveling at a consistent rate here of change, and gravity is having the same pulling effect on the ball as it goes up and as it goes down. And so based off the force at which the ball was hit, you can count on it being somewhat of a constant. Now, your physics teachers will get into more detail about the velocities and the force and everything that's applied to the ball. But in essence, if I know that it took me roughly, let's say, 3.75 seconds to get to the top, we know that that's basically an axis of symmetry. So the same amount of time it took me to get from here to here, it should take me roughly the same amount of time to get over here. So if I double that 3.75 times 2 would be roughly 7.5 seconds. Now, at this point, that's about the best that we can do. And notice that the problem says about how long. Later on, we will definitely be able to solve for this for a little bit more specific value for the exact time. But right now, 7.5 seconds is a good estimate. Now, second part of this problem says what's the maximum height the ball reaches. So we want the output part here to see what that vertex is. And so we're going to take that 3.75 for the vertex, and we're going to evaluate this problem at 3.75. And again, the better you get at using your calculator and punching all this in one entry line and coming up with an answer, better. That's going to serve you well later on. So that's 229, and of course that's representing feet. So the height of the ball reaches 229 feet. Alright, well, there's a good example of how we can use a lot of our graphing skills to answer word problems as well.